Well, this is the 17th. We talked about the normal curve and the empirical rule. So some book problems. I did 35 with you, actually. I'll show it at the end. But so here's a bunch of traits in the normal curve. It's bell-shaped. I will show a picture right now so you can see it. Looks like this. It's bell-shaped. Its tails go all the way. They get closer and closer to the x-axis, but they never actually touch. And here's a bunch of other stuff about it. The peak is at the mean. The mean and the median are the same for this, so the median is also at the peak. The tails approach the x-axis but never touch. We talked about that. The area under the curve is a proportion or a percent. So the total area is 1 or 100%. So if you got part of the area, it's less than 1. The inflection points on there are about 1 standard deviation away from the mean. Again, that's like it starts curving down about 1 standard deviation away from the mean, and it starts changing direction. I didn't draw this one great, but it's good enough. The empirical rule is another, they're actually really just properties of the normal curve still, but it's just interesting properties, and we use these to answer a lot of questions quickly without going through long, drawn-out calculations. 68% of the data is within 1 standard deviation of the mean, 95 is within 2, 99.7 is within 3. I'll show what that means now. So that means here's the mean. You go up 1 or down 1. That's within 1, 68% of the data. Within 2 is 95% of the data. Within 3 is 99.7. You can break the 68 up into 2 halves of 34 if you want. It's nice to remember that this is perfectly symmetrical. So if you do have to split something in half, it's the same on one side as it is on the other. All these traits have to be true for the above to be called normal. All the above traits have to be true for this to be called normal. So if you don't know if every single one of those things is true, you can't say it's normal, but you can say it's approximately normal. So if you got the basic bell shape and these look kind of true, pretty centralized bell shape, basically follows these rules even if it's not exact, you could definitely call that approximately normal and use the empirical rule for it, or use other normal stuff for it. We'll do a lot of calculations with this. So on this half, you saw this picture a lot. I'm just showing you one more time. Down here, this is number 35. It was about IQ. This is the first problem on your assignment. We were told in the problem that the mean was 100 and the standard deviation is 15 for IQ. So on average, people are at 100. If you go up 1 standard deviation, they're at 115. 2 is at 130. 3 is at 145, etc. So the questions they asked are what percent are between 70 and 130? Well, 70 and 130 I shaded, and that's that 95% right above, which is cool. It told us. So 95% of people have between 70 and 130 IQ. If you're like 145, you're doing way better than most people. You're like in the 99th percentile. So what percent are less than 70 or more than 130? Well, if the middle is 95, then the outside is the other 5. Together they make 1. 95 and 5 make 100. And then what percent is bigger than 130? Well, again, it's perfectly symmetrical, so that's exactly half of the last 5%. So we got 2.5. That's all. Ask me questions if you need in the comments, and I will try and answer as best I can and as soon as possible. See you guys tomorrow.